Right, if you watched the other video and the sound wasn't very consistent or annoying, I apologize. I thought I fixed it, but I guess I didn't, because what the heck do I know? So I'm using a different microphone, which I'm pretty sure should work okay. I hope so, because I don't want to have to do this yet again. All right, so I'm going to draw my triangle. See, I am solving them with the law of sines or cosines. So this is A, B, C. This is little a, which is 7, little b, which is 6, and a, which is 26.3. All right, so what I have here is a side-side angle situation. All right, so I got the first one drawn and labeled, and then I got interrupted. So sorry, but I do not remember the last thing that just came out of my mouth. So anyway, this is a side-side angle situation, which tells me that it is the law of sines, and but that is the ambiguous case. So once I get the angle, I have got to check to see if I could get more than one answer. Maybe I don't get any. Maybe there's no triangles that get created from this. We'll see. So I'm going to take the sine of A, which is 26.3, over little a, which is 7. That's going to be equal to the sine of B, which I don't know, over 6. So in my calculator, I've got 6 times the sine of 26.3 divided by 7. Now remember, that's not my answer. That's the sine of my answer. So that is, I need to do the sine inverse of the answer. That gives me the measure of angle B. I'm going to store that in B. So I've got the measure of angle B equal to, what was that, 22.320. All right, so because this is the ambiguous case, I could possibly have two different sets of answers. So angle B represents the acute angle, and I got to see what the obtuse angle will be. So remember, this is how you check. I've got that 22.320, and I know that that's one of my angles. To find the obtuse one, so like if this was a B1, what my B2 is, I would do 180 minus that, so 180 minus B. So if I do get to have a B2, then that would be B2, so I'm going to store it just in case. Store it in alpha. I'm going to do E because it's under the B. Store it there. So that 157.860, I don't know, it doesn't matter, it's in my calculator. And so to figure out if this would work, I take this, I'm going to add to it the angle I know I have is 26.3. Have that, I'm going to add to that 26.3. And that is more than 180. Since that's more than 180 with just those two angles, I know this one can't work because I don't have any room for the third angle. So this is even though it's the ambiguous case, I am only going to have one set of answers. So it doesn't need to be a B1, it's just B. So now I can find measure of angle C. So I know that the measure of angle C plus the measure of angle B from my calculator plus 26.3 is equal to 180. So in my calculator, I can do 180 minus B minus 26.3. That gives me 131.380. I'm going to store that in C. So the measure of angle C is equal to 131.380. Okay, so I found angle B, I found angle C. So I have this one, I have this one. I need to find little c. So the sine of 26.3 over 7 is equal to the sine of c, and that angle c is in my calculator, over little c. In my calculator, I did actually store it, so I can do 7 times the sine of c divided by the sine of 26.3. And I get 11.854. C ABC is equal to 11.854. And remember, if there's units, I got to make sure that I'm using my units correctly. There aren't any units on here. So. All right, so this one says, find the two triangles for this information applying law of sines only. So this kind of gives it away that you're going to get two answers. Remember, on the test, you're not necessarily going to be told that. Kind of like here, we got to make sure that we go and check. So here's my triangle. Draw this. ABC. A is 30 degrees. Little a is 6. B is 7. So if I wasn't told, hey, there might be two, this is a side-side angle situation, which tells you that it is the ambiguous case. And we have to use law of sines. So I'm going to do the sine of 30 over 6 is equal to the sine of B over 7. So that's going to give me 7 times the sine of 30 divided by 6. Remember, that's not my answer. That's the sine of B. So do the sine inverse of that. That's going to give me 35.685. So the measure of angle B is 35.685 degrees. And I should have stored it, so I'm going to go back and do that before I forget. Storing that in B. All right, so then I got to check to see if I would have more than one answer. So I'm going to do remember that you have an acute and an obtuse possibility. So the acute is the 35.685. To get this, it is the supplementary angle, so I do 180 minus B. Okay, I'm going to store it just in case I need it. Store it. This would be like B2. So I'm going to store it in what's under B, which is E. And that's my 144.314. So 144.314. So we know that this one works. This one, I have to add to it the angle they gave me, which was 30. So that's going to give me 174 something. Don't really even care what it is. And that is less than 180, which means I have room for a third angle. So this one works also. So I have the measure of angle B, which actually becomes B1. And then the measure of angle B2 would be the 144.315. All right, got interrupted again, so again, I have no idea what the last thing I said was. But, all right, we have found B1 and B2. And so there's two different sets of information that I have. And so now that I have A and I have B1 and I have B2, I can go ahead and find C1 and C2. So I know that 30 plus the measure of angle B1 that I have in my calculator plus the measure of angle C1 has to equal 180. And I know that 30 plus the measure of angle B2, which is in my calculator, plus the measure of angle C2 is also equal to 180. So in my calculator, I'm going to do 180 minus 30 minus B1, which is B. That gives me 114.315. So I'm going to store that in C, store alpha C. And then I'm also going to do 180 minus 30 minus B2, which is actually E. And then I'm going to store that in C2, which is actually F. So those are my two angles, the 114.315 and the 5.685. So I'm going to come over here and write those down. So measure of angle C1 is equal to 114.315 degrees, and the measure of angle C2 is equal to 5.685 degrees. Okay. So there's my two sets of angles that I have, my ones and my twos, and then I have to find side C, so little c1 and little c2. Guess what? Interrupted again. Okay, I think I'm good now. I think I can finish this. All right, so little c's is what I'm looking for. So I need to find I'm doing the law of sines again, so I'm going to do the sine of 30 over 6 is equal to the sine of C1, which I'm getting the C1 from my calculator, over little c1. And then I can also do the sine of 30 over 6 is equal to the sine of C2, which should be my calculator, all over little c2. That should be a 1. So hopefully, I actually stored these when I was doing this. So yes, I have them in C and I have them in F. Okay, good. So to find C1, I'm going to do 6 times the sine of C divided by the sine of 30. And so that gives me 10.936. Then I'm also going to do 6 times the sine of C2, which is really F, divided by the sine of 30. And that gives me 1.189. So those are my two answers. So C1 is 10.936 and C2 is 1.189. Okay, next page. All right, little triangle. Okay, there we go. So number 20. So I'm still solving the triangle here. So I'm going to start by drawing and labeling A, B, C. So little a is 11, little b is 5, c is 20. So this is side angle side. So when it is side angle side, that is when we're going to use the law of cosines. And I don't really have room to write the actual, just the formula itself, so I'm going to have to talk you through it as I plug it in because there's not enough room here. Then I'm looking for little c. This is going to give me c squared is equal to a squared, which is 11, plus b squared, which is 5 squared, minus 2 times, these two multiply together, 11 times 5, times the cosine of, cosine of c, but I want to make that 20. Remember, this is c, so this is c, and then this should be the other letters that we're using here. So I can do that all in the calculator in one step. So take the square root of 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 20. Double close there. So that gives me 6.529. So that's little c. I'm going to go ahead and store it. Alpha c. I'm going to write it down. Little c is equal to 6.529. Okay, so now I need to find one of the other two angles. I could find A or B. It really doesn't matter. So I will find A, which means I'm going to use the other version. So the cosine of A, which is what I'm looking for, is equal to, all right, so when I set this up as a fraction, whatever letter this is represents these first two that get squared are not that. So it's got to be B and C, and it doesn't matter what order. So we'll do B, which is 5 squared, plus C squared, but C is in the calculator, minus then whatever this is squared, or whatever the side is that relates to that. So it's 11 squared, all over 2 times these two multiply together, 5 times C. And C comes from the calculator. So in my calculator then, open my parentheses, so the numerator is all in the parentheses. So I get 5 squared plus C squared. Ooh, that's an I. Goodness gracious, what happened there? Okay. C squared minus 11 squared. Close my parentheses, divided by, open my parentheses, 2 times 5 times, oh, it's 25. 2 times 5 times alpha c. Now I'm going to double check that I didn't like some of those things I was hitting. That should be all of it. So when I get that, that's not my answer. That is the cosine of A. Since it's negative, that tells me that A is going to be an obtuse angle. So I need to take the cosine inverse. That is angle A, so I'm going to store that in A. That's 144.8 144.817. So the measure of angle A is equal to 144.817 degrees. So now I need to find, I have A, I just found that, so I need B. So I know that the measure of angle B plus 20 plus the measure of angle A from my calculator is equal to 180. So the measure of angle B is, you can do 180 minus the 20 minus angle A, and that gives me 15.183 degrees. So angle B, 15.183 degrees. All right, 21. This is my angle or my triangle. Got A, B, C. So little a is 9, B is 7, C is 5. So this is a side, side, side situation, which tells me it's got to be law of cosines. And I'm going to find an angle, so I can find whichever angle I want first, but it could be to your benefit to find the largest angle. Largest angle is across from the longest side. So A is the largest angle. We'll go ahead and go with that. So that means the cosine of angle A is equal to, it's this fraction. So this is A, which means the first two that go in here have to be B and C. So B squared plus C squared minus A squared. Then the denominator 2 times these two multiplied together. Then I can go to my calculator and open my parentheses, 7 squared plus 5 squared minus 9 squared divided by 2 times 7 times 5. And that gives me that. Remember, that's not my answer. That's the cosine of angle A. So I got to do the cosine inverse. That gives me that for angle A. So I'm going to store it in A. I'm going to come and write that down. So the measure of angle A is equal to 95.739 degrees. So now that I have the largest angle, I can switch the law of sines if I want to. There's nothing wrong with that. I'm going to go ahead and do law of cosines again, though, just because we're doing that. But law of sines would be fine, too, because I have the largest angle. Be careful switching too soon. So now I'll find B. So the cosine of B is equal to, all right, so if this is B, these first two have to be A and C. So A squared plus C squared minus B squared over 2 times A times C. Go to my calculator, and I've got my parentheses. So I have 9 squared plus 5 squared minus 7 squared divided by 2 times 9 times 5. That gives me the cosine, so cosine inverse gives me 50.704. I'm going to store that in B. Store alpha B. And then come over here. Measure of angle B is equal to 50.704 degrees. All right, so then I need to find angle C. So I know that the measure of angle A from my calculator plus the measure of angle B from my calculator plus the measure of angle C, which is what I'm looking for, has to equal 180. So back over here, I can do 180 minus A minus B, and I get for angle C 33.557. 33.557 degrees. All right. So now we're going to find the area of the triangle. It says find the area of a triangle in question 21. So I'm using this information from right here. I'm given all 3 sides. That's when we use Hurons formula. So area of the triangle is equal to the square root of S times S minus A times S minus B times S minus C. So remember, S is the semi-perimeter, so it's half of A plus B plus C. That's equal to half of 9 plus 7 plus 5, which is equal to 10.5. So when I substitute this in, that gives me 10.5 times 10.5 minus a, which is 9, times 10.5 minus 7, times 10.5 minus 5. All right, so when I did one of these in class, we went ahead and simplified, subtracted, and then put it all in the calculator. You can put it all in there like this if you want to, but I'm going to show you even another way to do it, which, you know, may be good, may be bad. It's just, you know, kind of preference, and I really just want you to know that you can handle things like this. So instead of typing in 10.5 over and over again, because I got to get the decimal, and then, you know, I mean, it's not like it's really that hard, but still. I can take this 10.5, and I can store it, let's store it in x. Oh, see, I didn't even type it in right that time. Huh. Okay, let me try that again. 10.5, let's store that in x. Okay. So when I type in my big old square root, instead of typing all those numbers in, x really represents s. And I could have stored it in s, but it's easier to get to x. So when it opens my little parentheses here, x times x minus 9 times x minus 7 times x minus 5. And because I stored it in x, this doesn't work. It's not going to solve for x for me. It doesn't work if I didn't store it in there correctly and all that kind of stuff. Everywhere you see an x, it's going to automatically put that 10.5 in there for me and do it all together. And there's my answer. That is the area of my triangle. So the area of the triangle is equal to 17.412 units squared. Okay, area has square units. If there's units in the problem, make sure you use them appropriately. All right, next one. Let me draw this one since I already have it going on here. A, B, C. So B is 101, little a is 10, little c is 22. So this is a side angle side situation, and when you have side angle side, that's when you get to use the formula that looks more like the actual area formula of a triangle. So it's 1/2 the two sides that you have, so in this case a times c, times the sine of the angle you have, which is b. And these three letters shouldn't match. Like, they have to all three be different. That's how you get the whole side angle side thing. So when I substitute this in, I get 1/2 times 10 times 22 times the sine of 101. Okay, I'm just going to let the calculator do all that for me. So I'm going to do the 0.5 times 10 times 22 times the sine of 101. Okay, there we go. So we get 107.979. So the area of the triangle is equal to 107.979 centimeters squared. All right, so that's the end of what you really had to do, and I told you today in class that these next three, they weren't on the test. I decided to go ahead and put one on there, but because I already told you they weren't going to be on there, I'm going to count it as an extra credit question. My suggestion to you would be, if you haven't done these problems yet, to stop or pause this video and then do these, and then come back and check yourself. So it's not just me doing them. All right. So, like, for real, if you haven't done them yet, pause the video. All right, so we have two airplanes leave Kennedy Airport in New York at 11 a.m. The air traffic controller reports that they are traveling away from each other at an angle of 103 degrees. So we'll say, like, this is the airport. There's no whole airport. Okay? And I know they don't leave, like, directly from the airport itself, like, on top of it, but we're just going to pretend. So the two airplanes leave, and they're traveling away from each other. So here's one of them. Here's the other one. They're going in opposite directions. Those are my little stick planes here. So we'll make this the DC-10, and this is the L1011, whatever heck that means. So they're traveling away from each other at an angle of 103 degrees, and it gives me the speed at which they're traveling, and I want to know how far apart they are at 11:30 a.m. So basically I'm looking for this, how far apart they are. Well, in order to find that, I have to have some more information. I either have to have more angles, or I have to have some of the sides. So let's think about what we have. I know how fast it's traveling, And so to figure out how far it went, I need to know how much time has passed. Well, it's 11 a.m. to 11:30, so that's half an hour. So if we start with the DC-10 and we're looking at this one right here, it's been traveling for half an hour at 509 miles per hour. So you can set up a proportion. Hey, I mean, this one isn't, the numbers aren't crazy here, so I know you can kind of do it in your head and reason through it. But remember, if it is a rate, make it into a proportion every time. It makes it easy. It's not that big of a deal. So for the DC-10, if it's 509 miles in every 1 hour, then I want to know how many miles. I probably shouldn't use X because there's an X there. We'll call that Y. Just if this will incorporate Y over, I want to know how many miles in half an hour. Right? It's just a simple rate. So I cross multiply and I divide. So basically I'm just taking the 109 and the 509 and multiplying it by 0.5 because then I divide by 1, or taking dividing it by 2, which you probably could reason through with the time anyway. So 509 divided by 2 is going to be 254.5. So that's this, and since that was the DC-10, this is the 254.5 miles. That's how far it's gone in half an hour. So same thing works for the other one. That's 503 miles for every 1 hour. I want to know how far it's gone, so Z, miles in 0.5 hours. So same thing. I'm just dividing by 2, multiplying by 1/2 or whatever. So half of 503 is going to be 251.5. So this is 251.5 miles. So now I have this side angle side going on. I can find that right there by using the law of cosines. So x squared, which is the side I don't know, is equal to the other two sides squared and added together. So 254.5 squared plus 251.5 squared minus 2 times 254.5 times 251.5 times the cosine of the angle across from x, which I know, which is 103. And I can do that all in one step on my calculator. So square root of 254.5 squared plus 251.5 squared minus 2 times 254.5 times 251.5 times the cosine of 103. So all of that gives me that right there. So x gives me 396.004, and that's a distance, so that's miles. Now, nobody asked me for x. Like, I use that variable. I could have called it anything, a, b, c, whatever. So I can't just leave it like that. I have to actually answer the question. So what it asks me for is how far apart are they at 11:30, so I decided at the beginning that that's what that distance is. So this is distance apart for the planes, or something to that effect. That's probably not the best wording in the world, but you get the idea. And it's okay to leave the x in there. You just can't say, hey, x equals this, because nobody told you to solve for x. Alrighty, next one. Two fire stations are located 56.7 miles apart. So here's my two fire stations, and they are 56. Oh my gosh, that's an A. What the heck? I'm telling you, my brain does not always agree with what I'm doing. 56.7 miles apart. And this is at points A and B. So this is at point A, this is at point B. There's a forest fire at point C. Okay? And so point C out here somewhere. I don't know where, but whatever. Here's point C. And so it makes this triangle. Right? And it says angle CAB, this one is 54 degrees. And CBA is 58 degrees. So it says which fire station is closer and then how much closer? Well, this question right here, we can answer right now because you should know which one is closer. The one that is closer is the one that has the shorter side length, and you can tell that from these two angles. Of these two angles here, this one's smaller, which means the side across from it has to be the shorter side. So station B is closer, right? So I can go ahead and say that station B is closer by, and I don't know what's put there yet, like by how many miles, but now that I've at least thought through that, if when I'm done, that's not actually what I get, then I got a problem somewhere. And so to make sure that you're not confused about things, like station B is across from this side, and so this side right here is related to this angle. So we would actually call this little b and this little a, but that might confuse you over there. So you may not want to use a and b here so that you don't get that all mixed up. I'm going to use x and y just so that I don't mess this stuff up. Okay. So because I have angle, side, angle, in order to solve this, it's going to be the law of sines. So the sine of 68, no, the sine of 58. Oh, no, it's the sine of 68. Okay, I got ahead of myself there. This is the side I have. I need angle C. So in order to do that, I know that 54 plus 58 plus the measure of angle C equals 180. So when I take 180 and subtract 54 and subtract 58, I get 68 degrees for angle C. I got ahead of myself there. All right, so the sine of 68, even if I had tried the 58, I wouldn't have enough information to solve it without getting there anyway. All right, so the sine of 68 over 56.7 is equal to the sine of something over, well, we'll go ahead and do A first. The sine of A, which is 54, over the side across from A, which I called Y, just because. So in my calculator, I can do 56.7 times the sine of 54 divided by the sine of 68. Okay. And enter. So I get 49.474. I called it Y, so I'm going to store it in Y. Again, you can call it whatever you want, but Y. So I'm going to write this down, and Y is equal to 49.474. And just again, so that you're not, what are the units here? Miles. It's not really my final answer there, but I need that, and so I'm going to put this over here. So this is 49.474 miles. Then I need to go and find the other one. So again, the sine of 68 over 56.7 is equal to, now this angle, 58, sine of 58 over x. So in my calculator, 56.7 times the sine of 58 divided by the sine of 68 gives me that for x. So I'm going to store that in x. Come over here and write that down. X is equal to 51.861 miles. So this is 51.861 miles. So I can see now that I've found those, and it's asking me which station is closer, right? Here are my two answers. And clearly B is closer, right? Because line segment BC is shorter, and that's what I had said from the beginning, so we'll feel good about that. Then it asks how much closer. So then I need to subtract the two. So what I'm doing here to get how much closer it is just basically just x minus y. This length minus this length. So that's what I'm going to do in my calculator. X minus y. There's my answer. And so station B is closer by 2.387 miles. There you go. All right, last one on here. Parcel of land. Okay, if you don't know what a parcel of land is, that's an odd way to say it, but some land, that's all that really matters. Doesn't matter if you know what a parcel is. So some land is in the shape of an isosceles triangle. So here is my isosceles triangle. The base has a length of 425 feet. The other sides of the triangle, which are of equal length, which they shouldn't have to tell you that if they told you it was an isosceles triangle, meet at an angle of 39 degrees. And how long are the other sides? So I'm looking for the other side lengths, x, and they're the same, so I'll call that x. In order to do that, I've got to have some more information. Well, this is an isosceles triangle, so I know that the base angles are congruent, so I can call them y. So what I know here is that y plus 39 has to equal 180. So 180 minus 39, and then I divide by 2. So that's one of the angles. I'm going to store that. I called it y, so I'll store it in y. So y equals 70.5. So that's what this is here. 70.5, and so is this one, 70.5. All right, so now I have angle, angle, side, or angle, side, angle, which means I can use the law of sines here. And I really only have to do it once because the two sides are congruent, so I don't need to do it over and over again. So I can take the sine of 39 over 425, and that's equal to the sine of 70.5. I can actually type that in because it's not rounded, over x. And it doesn't matter which one, because the same thing's going to happen to both of them. So even though I stored it, totally unnecessary. I mean, I can use y if I want to. Probably just as many keystrokes, type it in, whatever. So I'm going to get 425 times the sine of 70.5, and then divide that by the sine of 39, and enter. That is my x, which that means that's the length of the legs. So x is equal to 636.596 feet. And again, nobody asked me to solve for x. I just chose that variable. You can use whatever you want. That is the length of the legs. Or length of each leg. That's what I said. And I think I got that number right. 636.5. Yes. Okay. All right. So there you go. That is everything. Remember the other one, I will post a worked out copy, just worked out by hand, and I will put it in the Schoology folder for you.